Okay, so let's begin. Let's talk about probability. Now, I happen to think that probability and statistics is pretty important stuff. I would say probably more important for society, people in general, to understand this more than algebra. Because really, I don't know, in my regular life, I don't do a whole lot of algebra. I don't. I'm not gonna argue with that, right? But I would say that it's more important for a general population of citizens to understand probability more than algebra. Okay, because I mean, let's face it, when you're talking about like even the weather, right? Understanding what the probability of rain means. When you're talking public policy, like politicians, understanding what percentages, and even statistics, and how statistics can be manipulated and forced to sort of make people believe a certain thing. Anyways, there's my little rant for the day. So what is probability? It is a way to say how likely an event is. It is written as a number between 0 and 1. So it's on what we call a spectrum or a continuum, right? Anywhere from 0 to 1, where 1 is absolute certainty, will always happen. For example, what is something that will always happen? Guaranteed. Well, they do go down too. How about sun comes up? Right? 100% certainty that the sun will come up tomorrow, as the song goes. Robert, you should take those earbuds out. Now, 0% probability will never happen. What might be an example of something, Robert, that never happens? That's never going to happen. Oh. Can't believe I picked you. Okay, so you mispronounced it.
Oh! Don't look, Robert.
Here, let's go with something that we can all agree on. Mr. Bennett's hair will grow back.
How many cups do Toronto have?
In total, they're the number 2 team in the league.
How many does Jets have?
Less than that. 0.
So there's your...
There you go. There you go, yeah.
yeah.
Now, to be fair, the Leafs have been in the league a few years long.
Yeah. And when was the last time they won?
1967.
Wow, that's like...
When's the last time?
We're not going to win it up again.
That has nothing to do with it.
What's the last time Jets won?
Jets won 2 Avco Cups in the old WHA. So yeah, we'll never have Mr. Bennett's hair will grow back. So somewhere in between, like, 0.5, 50-50, if I'm like, like, you know what, Robert? I went up to I had to grab some change yesterday, and I went, oh my God, I think I spent my Leafs loony. Because oh, it was still there. I was so worried. Oh, I was freaking out because I remember I spent some change. Okay, so I got a toonie here. So if you flip it, what's the chance of heads?
50%.
50%, right? Exactly 50-50. Right? Okay. What do I got under there? That's it. Okay, so you can write probability in a number of different ways. Okay? As a fraction. 3 divided by 5. Right? 3 over 5. In French, they say 3 on 5. Anybody do French immersion in here? No? As words, 3 out of 5. Or as a decimal, 0.6. Or as a percent, 60%. All of these are the same. Right? They're all the same. 3 out of 5 days, something happens. As words, 3 out of 5, right? Or 3 over 5. Or how do you get the 0.6? Right? To get 0.6, you would go 3 divided by 5, right? To get 60%, you take that 0.6 times 100. You need to be able to handle all those different sort of ways of saying it. They all mean the same thing. Does that make sense? Yeah? Like they might say like 70% chance of rain. I think today, let me just check. I have the weather up here. It says 60% chance of rain showers or flurries.
Oh.
So what that means, the way I've had that explained to me is,
That looks like bullshit.
oh, kind of escalated. What that means is the way I've heard it explained to me, right? Is she okay with that, right? Or if you're not, just give him a smack. Okay. Well, keep your hands to yourself, right? When the weather is like this, 60% of the time we get rain or flurries. That's what it means. Okay, I'll keep the phone down, please. Come on, stay with me. Josh, put it down.
Yeah, sorry, sir.
Stay with me here. I'm teaching, man.
Yeah.
Okay. Oh, here we go. 70% chance of rain tomorrow. Write this as a decimal. So how do I write 70% as a decimal? Percent means per 100, right? Get that earbud out there, Elvis, right? So that's going to be, get that earbud out. 70%, that's going to be as a decimal, 0.70% per 100. As a fraction, now 70% means 70 per 100, or I guess 70 out of 100. Or 7 out of 10. Lane, put the phone down now. Come on, you guys. You've got to stay with me. Phones away. Please. Or words. 7 out of 10. Those are all different ways to say that. Here's another reason why people need to understand probability. The lottery. Like people buy lottery tickets. I admit I've started buying a few lottery tickets. But I know that my chances of winning are next to none. Right? Next to none. You're much better off, and I'm not suggesting that you do this, I'm not condoning it, but you're more likely to win something like at a 50-50. Like yesterday I was at the Zerker recital, so there might have been maybe, I don't know, 400 or 500 people there. If I buy one 50-50 ticket, I get a 1 in 500 chance of winning. Now, my winnings are a whole lot less, but I got a way better chance of winning that than I do 649.
Do you want 649? Would you just take off by a weekend?
See you later.
We'll buy it from.
You know what I would do, Robert? I would buy you a Jets playoff ticket. Just because I'm a nice guy.
No.
No, I would.
I think you would buy a wig and disappear.
Buy a wig and disappear. Well, I hope you never win the lottery, Robert. Okay, 55% chance the RBS, I don't know who that is, basketball team will win against Carmen. As a decimal, 55%, 0.55. You need to be able to do that. Fraction, 55 out of 100. Can we just leave it like that? We could reduce it, but 11 out of 20, you're right. Both divisible by 5. Words. Okay. Well, I guess 11 out of 20. I guess you could say 55 out of 100. Do you know what the odds are of winning 649? Do you know? 1 in 13 point, I think it's 9 million.
Pretty good odds.
You don't have very good chance.
Your odds goes up by 1 each time. And 5 out of 3.9 million.
25% chance you'll win playing the slot machines. See, now they're rigged against you as well, the slot machines, right? Oh, sorry, did I say 25%? 2% chance. Decimal, 2%, that's going to be 0.02, not 0.2, 0.2. 2 out of 100. 2 out of 100, or 1 out of 50. 1 out of 50. Oh. 50. Well, I mean, it's all computerized, first of all, right?
They have a cool down time where you won't win anything.
They have a what?
They have a cool down time.
Yeah.
I know a guy who went and played slots and only had $20. He came out with like 300.
You can win. I mean, you can win. It's just that the way that probability and those things work is that it's over time, right? So, I mean, you might win for a while, but eventually, I mean, it's like flipping a coin toss, right? Like, if I flip a coin, what are the chances of me flipping, say, 10 heads in a row? Pretty low, right? Well, we get okay, pretty low. But if I flip 9 in a row, what are my chances of flipping the 10 heads? 50%, right? Your chance of getting the last one is still 50% if you get that far. So the slot machine is kind of like that. You might win early on, but eventually because it's not 50-50 that you're going to win, right? There's one thing that really bugs me. People think, well, you're either going to win or you're not going to win, so the chance of winning are 50%. That's not true, right? People need to understand that. When you buy the 50-50 at the Kings game, it's not, 50% chance I win, 50% chance I don't win. There's like 1,000 people in the rink that don't win. It's not 50-50.
That's cool. My dad won that.
Yeah?
Went to
To a Kings game?
Yeah.
Yeah? Okay. Okay, so probability is how likely an event is. Now there's two types of probability. There's what's called experimental. Do I have the highlighter? Where is the highlighter?
How long are you working, no?
I don't know. You can look ahead. Try to use like public filter there, Bodie. Experimental probability. I want my highlighter. Can't find it. Probability based on what we have observed in the past. Like if we've actually done a trial, if we've done an experiment. Okay? Like for example, bottle flip.
Oh, it's 50% you're going to do it.
No, it's not. Right? And some people are better at it than others. So if you do it 100 times, that would be your experimental probability. Right? Flipping a coin is theoretical. Theoretical, based on the number of possible events. So theoretical is like done by math. Experimental is done by experiment. Okay? Theoretical can be used when we do not have previously observed events, or like if the experiment is risky or dangerous to perform. Josh, put the phone down. Stop. Focus, you guys. Usually, experimental and theoretical probability will be close or the same. Okay, so you get like probability. Now, if you are good at probability, you can make a lot of money. There's a job called an actuary, and their job is to figure out what the chance of something happening is. So when you buy home insurance, we've talked about home insurance. When you buy home insurance, there is an actuary somewhere that figures out, based on your home, what the chance of your home catching fire is, and that's how they figure out how much to charge you for a premium. Same thing with life insurance, right? They look at your age, your health, your past, your family history, and they say, this person has a 18% chance of dying before age 75. This is what we should charge them for life insurance. Because the insurance companies are not in it for you.
No.
They're in it to make money. That's their business.
I feel like you can low-key cheat someone out kind of thing. Like you could just talk about like you know what you're doing, but
Do you think that they filter that out already? They overcharge everyone to account for that charge. When you go and get a new phone and they offer you insurance on it, they know what the chances are of you busting your phone, and they charge the appropriate premium so that they still make money. Right? If everyone in the room pays an extra $20 a month in insurance, they make sure that they don't pay out more than $300 in insurance money out. They always take a little bit for themselves. They're in the business of making money. Okay. Pretty much any extended insurance policy. Like when you buy even like a toaster oven, and they ask you, do you want the extended warranty? It's a moneymaker. They know that toaster is likely going to last 6 years. not 2. More rants for the day. Experimental probability is the probability of an event occurring based on what we have seen happen. To find experimental probability, and I don't know how much you guys have to fill in, do you? It's the number of times the event occurred divided by the number of trials. I'm going to go back to the coin flip. Right? So if I flip my coin 100 times, and I count the number of heads, and let's say I get like 48 out of 100, well, what's the experimental probability? 48%, right, for a coin flip. Because some coins are not what they call fair. Oh, to get the earbud out. Right? Some coins are rigged. For whatever reason, there might be a little bit more weight on one side, right? So you might see that in the exam. You might see a fair coin. That just means that it's not rigged. Okay? Number of times the event occurred divided by the number of trials. Are we good? Theoretical. To find the theoretical probability, it's the events you want or are looking for. It's the number of, we use the term favorable outcomes. Favorable outcomes over the total possible events. So favorable just means events that you want or are looking for. You're counting for number of heads, or you're counting for number of days that rain. You're counting for number of planes that crash. So we're going to be looking at this. In a bowl, there are 4 oranges, 3 apples, 6 bananas. Christina picks a piece of fruit at random. What is the chance that it is an orange? What is the probability of Christina picking a banana? And what type of probability is this? Experimental or theoretical? Well, let's do the last one. Is this experimental or theoretical? Is she using math, or is she actually doing an experiment? She's actually picking a piece of fruit at random. It is experimental. She's doing an experiment. Okay. We are going to the theoretical odds now. So she's doing an experiment, but these are what we call the theoretical odds. So what is the chance that she's picking a banana? Well, how many bananas are there?
6.
There are 6. So she has a 6 out of, how many are altogether? 4 plus 3 is 7, plus 6 is 13. She has a 6 in 13 chance of getting a banana when she picks it up. 6 out of 13 is 0.46, or you might say 46%. Oh, I did banana. I was supposed to do orange first, wasn't I? Sorry. What's the theoretical of an orange? How many oranges are there? There's 4. 4 out of 13. 0.31 or 31% chance. Guaranteed they're going to ask you a question like this on the exam. Virtual guarantee. 99.9% chance. Okay? Adam and Blake are playing Call of Duty. I have never played Call of Duty.
What?
Never. Why would I? Never. I don't think I've ever actually seen it.
Did you ever play Rock Band?
I've played Rock Band.
Yeah.
Pac-Man. Yeah. Space Invaders. That's pretty good, yeah.
Red Alert?
No.
No, never heard of that.
Donkey Kong.
Donkey Kong, Mario.
Mario, yeah. I'm pretty bad at Mario Kart.
Frogger.
Frogger. No. No. Okay, so they record the games and who won. What is the theoretical probability of Adam winning? Well, okay. In this case, is it 50-50? Yes, because there's only 2 of them playing. He has a 1 out of 2 chance, 50% chance. That is based on random, right? It's luck. It's not based on skill, right? Some things require no skill. Flipping a coin, no skill. Heads you win, tails you lose, right? Call of Duty, like, if any of you guys play me, who's going to win? You're going to win. I don't know what I'm doing. What is the experimental probability of adding one? How many wins does he have? 1, 2, 3. He's only got 3 wins. They played 8 games. 3 out of 8. 0.375 or 38% chance. What would be the chance if it was Mrs. Pazlowski and I playing Call of Duty?
Not good for me, I don't think.
Probably 50-50. It'd be the worst game ever because neither one of us would know what's going on. Actually, you know what I'd like to do in school? I think it's of the last 15 people at a carnival booth, 6 won a prize. What is the experimental probability that the next person at the booth will win a prize? Oh, experimental probability, right? If 6 won a prize, I don't know if I like this question.
What a prize. Total number of.
I guess it would be 6 out of 15. I guess 6 out of 15. I think 0.4, 40%. Quite often these you have to really read it carefully. That's the
Yeah.
Jenny works on an appliance store. She recently sold 20 appliances, 8 of which are ovens. What is the experimental probability that the next appliance Jenny will sell will be enough? Well, I guess 8 out. Oh, not 120. 8 out of 20. Well, it should be 4 out of 10 or 2 out of 5, right? As a decimal, 8 out of 20. Of course, it's 0.4. What am I doing? 40%. Okay. Okay, so you've got more practice problems in the book. There's a short assignment there as well. Some of you owe me a lot of assignments, projects. I marked this weekend, so everything that was in I should have marked. I will go hand some stuff back. Okay?